So that's a Thursday anyway. This is the card we're working on today. And there are actually two sets of slides. I'm going to walk through this set of slides today. Just checking out people are okay. They can hear me and see the screen. Yeah.
Yep. Yes.
Okay.
Yes.
So I'm going to walk through this set of. I'm going to walk through this set of slides today. There's a second set of slides here, and I'm actually going to record a lecture associated with this set of slides. I've done it already. Actually, it's about 40 minutes long, so it's not a full 2-hour lecture. Kind of running out of time because next week is going to be my final session with you. So I'll put that recording for this set of slides up this evening, and what it covers is the whole area of designing React apps. It's something that I've ignored up to now purposefully. So in terms of designing, I mean, how do you come up with a component hierarchy, and how do you decide what components should be stateful, all that kind of stuff, which I have kept saying we'll look at it later on, but the time is now really. So rather than take it up in a lecture, because it's kind of theoretical, there's no code involved, but have a look at the video anyway when it's available to you. So we're going to work through this set of slides today. And these are the topics I'm going to go through. They're kind of independent, really. We've done quite a lot now in React at this stage, so we've got a fairly solid foundation. So I'm going through these 4 topics today. They're not really, the sequencing of them isn't necessarily important. I could cover them in any order at all, really. In fact, I was going to do the virtual DOM stuff last week, the second on that list there. But I reckoned I wasn't going to have time to do it, so I left it out and bringing it in this week. So anyway, there's 4 topics that I want to get through. The first one is navigation or routing. And if you had a chance to work through last week's lab, we've actually done some, you've coded some navigation in relation to a React app already. So we've kind of put the cart before the horse. So I'm going to cover some aspects of implementing navigation or routing in a React app. I'll do some of it this week and more of it next week. And that's where I'm going to start off. Then I'll talk a little bit about the virtual DOM, talk about design patterns in relation to React, and finally something called custom hooks. We know what hooks are, but we can actually implement our own hooks. Typically, we can wrap hooks that we get with React, we can wrap them inside our own function, and we would call that function a custom hook. So it's going to be quite short, that last topic. So navigation. Navigation actually is not implemented by React itself. We need a separate library to do that. There are a couple of them. Probably the dominant one is one called React Router. So that library is actually maintained by a completely separate group of people. Really, it's an open source. It's an open source project or library. It's strictly speaking, it's got nothing to do with the React engineering team, but it's obviously very much aligned with the way React is evolving over the years. But it is a separate library. So what's navigation all about, or what's routing all about? It's about this ability to have multiple views within your app. I'm saying there that it's multiple views or flows. What I mean by a flow is the typical example of a flow would be if you take your checkout procedure in a kind of shopping cart kind of environment where you're going through a number of steps to complete the checkout. That's what we mean by a flow, or what I mean by a flow there. We won't implement it, but it's essentially the same thing. It's this idea of having multiple views. We could call them multiple pages within our app. And the key thing, though, is the second point there, that as we navigate from view to view, i.e. from page to page, the URL in the browser changes as we do so. And that's classic web behavior, back to the days of the static web. As we moved from page to page in a static web, then each page had its own unique URL. That's a really nice characteristic that we want to have in our browser-based apps as well, React apps. And so we can achieve that, and the library does it for us, really. And so this idea of keeping the URL in sync with what the user sees on the screen is really the nice thing about modern day web browser-based apps. The very first generation of web-based apps, they weren't called single-page apps then. They were kind of called, I think they were called Ajax apps, which is kind of a reference to the technology that was being used. But in that first generation of browser-based apps, you didn't get that behavior. The URL in the browser remained constant, even though as the user interacted with the app, what they were looking at changed, and they were getting multiple views, but the browser's URL wasn't changing. And that's very much against the whole kind of first principles of the web, which is kind of my third point there. So what I'm really talking about there is addressability, this idea that each view stroke page has its own unique URL or its own unique address. And that is a core characteristic of the web. And so we now have that. Those 3 points there, addressability, information sharing, deep linking, they're all kind of mean the same thing, really. The whole point, the whole advantage of addressability, if we think back to the days of the static web, is that if I found a web page and I wanted to share it with you or tell you about it, all I had to do was give you the URL of the web page. I didn't have to tell you to go to the home page of a particular site and then follow a particular procedure to get to that page. I could just give you the URL and it brought you straight to that page within whatever website it was. We'd like the same thing to be true for our React apps. And we can achieve that. And the last point there I've already made, that this whole navigation is implemented in a separate library. And the one we're going to use is React Router. So example 101. Supposing we want to have this set of views stroke pages in our app. I want 3 separate views and they each have their own unique URL. Now what I'm saying there is that if the URL in the browser is just slash, then I want the home component to be mounted. Now that component may have children and may have a whole hierarchy underneath it, but home will be at the top of that hierarchy. If, however, the browser's URL changes to this, then the home component is removed and the about component is swapped in instead, and its children are now kind of active, if you like. Similarly for this third scenario, there's no link between the name of the component at the top of the hierarchy and the URL. That's just coincidental. So that's my objective. I have 3 views, 3 pages with these specific URLs, and these are the components that I want to have at the top of my hierarchy at any particular point in time. So how do I express that programmatically? And the answer is I do it like this. And you could kind of make sense of it, and this is very similar to what you had in last week's lab. Now, so you implement, so we call this our routing configuration. You implement this typically in the component at the very top of your hierarchy, of your component hierarchy. And it typically doesn't have anything else other than routing logic in it. So this component, which I've called app, would be at the top of this hierarchy. And, you know, okay, the outer component is browser router. That's kind of boilerplate. Switch I'll come on to in a second. But these are the 3 implementations of the routing that my routing requirement on the table on the left. And you can kind of make sense of them by just reading it. It's saying, so each route component is saying if the URL path in the browser is this, then essentially make this component at the top of your hierarchy, and so on for the other 2. The 4th entry is your default entry, the redirect. The 4th entry is the redirect entry, and that's kind of your default one. So that would mean if the URL in the browser is none of these 3, then what do I want to do? Well, I'm telling it to essentially force the URL to go back to this value, which means my home component is going to be mounted. So I'm essentially avoiding the 404 error by including this 4th entry. And that's my full routing configuration. What's the purpose of the switch component, which is wrapping those? it's a bit like a switch statement a case switch statement in normal programming. So what it means is that only one of these routing entries can be active at any one time, which is probably what we want anyway. What the role of the browser router component, it actually plays the role of keeping an eye on the URL address in the browser itself, and if it changes, in other words, if that kind of event happens in the browser, then it kicks in and it makes a routing decision, and it consults these routing entries here to decide what to do. In other words, what component to remove and what component to put on top of the hierarchy. Notice down at the bottom now that in the react.render, we actually specify this routing component, my app component. So as I said, that's typically the component at the top of your hierarchy. So I think, and it's nice and declarative, we would say that routing configuration is expressed in a declarative way, which is kind of consistent with the whole programming model of React itself. In the earlier versions of this library, it was more a procedural kind of implementation. So it wasn't really aligned with React that well. So yeah, it's a declarative syntax for expressing routing. The browser router does what I said it does there. It tries to find a match between whatever URL is in the browser to the path variable of your route components. The path props, sorry, these are essentially components. These are props to this particular component. Oh yeah, I'm using the term mounted there. I used that term last week, if you remember, this idea of a component being mounted and unmounted. So that applies here again today. There is a slight difference here. You can see that this entry here has an extra prop called the exact prop. And so what it's saying is that the URL in the browser has to be exactly that. And if it is exactly that and nothing else other than that, then I want this component to be mounted. The other two don't have it. I could have used the exact prop in these other two as well, but I didn't. That is a prop, by the way. When you see a prop like that, you're effectively saying exact equal to true. It's a Boolean prop. And I've already mentioned the purpose of the redirect component in that configuration. The switch statement only allows one of the routes to be active. So if we didn't have the switch, then in general, maybe more than one of my routing entries here might actually be active at any one time. It's very rare that you would want that behavior, though. We tend to wrap them in a switch all the time. Anytime I've seen routing configuration, it tends to be always wrapped in a switch statement. And that's the React DOM. Now, there's a whole series of samples accompanying this set of slides, and you'll get them off the website, obviously. So it's this archive here. Just download it, unzip it, run npm install on it. And when you do that, you will get this. Now, I've used the Create React app to implement this just to make life a little bit easier for myself. But you can see my source folder has a whole series of sample folders, and I'm going to walk through these samples, some of them today, the rest of them next week. And so what you need to do, if you want to get any particular sample to run, what you need to do is go into this index.js, which is at the very top of the file hierarchy, and it only has one line of code. So you just simply change that to whatever sample you want to be kind of to execute, save it, and then Create React app will go through its transpilation, etc. So that's the way I decided to structure this stuff. So run npm install and then run npm start. So if I run npm start, and very quickly, I'm going to run through, just look again, go into sample one, because we can see it's referring to sample one, the sample one folder. So if I go in there, I kept it simple for myself, really. I have one index.js in there, and it has all of my components, which is kind of against the grain of how we should structure these things. But so I've put the about component. This is Maria, my about page, the inbox component, the home component, the app component that has the routing configuration that we've talked our way through. Okay, so in terms of just getting it working, so I've kicked it off, and we can see the URL in the browser is just /. So based on my routing configuration, it should mount the home component. And as we saw from the code, the home component just generates this. Yeah. If I manually, which is nice, but if I manually change the URL in the browser to /about, then having changed it, the browser router component in my routing configuration picks up the event associated with a change in the browser's URL address bar, and it makes a new routing decision. And the upshot of it all is that it actually mounts the about component and any of its children, which it doesn't have in this case. Oddly enough, and similarly for the inbox, if I typed in inbox here, it would mount the inbox component. If I did about us, now that doesn't match any one of my paths in my routes. What's going to happen? Okay, it doesn't find a match, which means it's actually going to use this entry here. And that tells it to change the URL in the browser back to /, which means that the home component gets mounted. Yeah. Mm-hmm. If I changed it to /about /us, what do you think is going to happen? It's not going to be what you think. I don't think, but oh, sorry. That's not what I wanted. I bring up the about first, sorry. That's the about, and then if I go /us, okay, it didn't change it. You might have expected to go back to the home page, but it doesn't. And it doesn't because I didn't specify exact in this entry here. So once it's able to match up this part here with the URL in the browser, then it's saying, well, that's a close enough match. So it takes that, it decides to mount the about component. Now, if I stuck in exact here, then it will change its behavior to maybe what you expected it to do. If I change it to that, save it, and now go, well, it's done it already actually. If I go /about, and now if I tag on the /us, because it's not an exact match, it brings me back to the home page. So the exact does have a role. So you might expect to, well, why not use exact all the time? You could. There may be cases where you'd rather not. Maybe I always want, even if the user types in /about /us, it brings them to the about page anyway. It's close enough kind of approximation. So it depends on what you want to achieve. Okay, that's the 101 example of routing. The next thing is hyperlinks. Obviously, if we've got routing and navigation, we're going to have hyperlinks. Now, there is a specific component that comes with the React Router library called the link component, and you should use that if you want to, I'm saying there, if you want to implement navigation internally within your app, then use the link component provided by the library rather than using the HTML anchor tag itself. The anchor tag will work fine in most cases, but you get some extra benefits by using the link component, which we'll see later on. So the rule generally is use link if you want to navigate within your app. If you want to include a link to some other page or app outside of the scope of your own app, then you can use the anchor tag, all right. So sample 2 has examples of basic examples of links. So the home page for sample 2 will render this page here. So I've got 2 standard kind of hyperlinks, and behind these hyperlinks, this is how they're implemented. So I've kept it very simple. It's just an unordered list, but the key part here is where I'm using link. So the link component takes one prop for now anyway. The prop is the top prop. And so when the user clicks on this link, for example, the link component kicks in, and what it does is it changes the browser's URL to whatever you've set the top prop to. And if you change the browser's URL address bar, then we know from the previous slide that the routing configuration picks up that event and makes a routing decision. So in this case, this /about, because we changed the browser's URL to that, it's going to mount the about component. You can look at sample 2 yourselves. There's no other surprises other than that in it. So that's link. So implement your hyperlinks using link rather than anchor tags if they're internal links. I've never had to use it, but you see, in this case here, my link isn't wrapping any other component. Sometimes you might want to wrap a link around another component. In other words, you want to hyperlink whatever that component renders onto the screen. Now, in some cases, the link won't work, in that when you click it, it won't carry out the navigation that you want it to. So if that arises, then there's an alternative component called the link container component, which has the exact same interface, if you like, as the link component. I've never had to use it so far, but if you do come across a case, especially if you're using a third-party library, UI library, and it provides a component that displays maybe some sort of button or whatever, and you want to wrap that button inside a link, and clicking on it just won't get it to navigate for you, then change the link to a link container component, and that should get it to work. Next topic is dynamic segments. It's an odd name. It's what React Router calls it, but a more common term for what I'm trying to explain here is parameterized URLs. A parameterized URL is a URL where part of the URL is actually a variable or a parameter. Very simple abstract examples. Maybe this might be a valid URL for a particular app that you're developing. And the understanding is that 22 here is, let's say, a user's ID. It's up to you to design the URLs for your app. Okay, so I've decided this is a valid URL for my app, and I want the 22 to be interpreted as a user's ID. But of course, the value could be anything. It's variable. It's a parameter associated with the URL. And presumably the component that is mounted as a result of the browser's address bar changing to this, presumably that component wants to access this value and, I don't know, maybe make an API call or something like that. So the question is, how do we tell the React router that the 22 here is not a static string, it's actually a parameter? And secondly, in the component that's mounted as a result, how does that component access that parameter value? They're the two questions that we need answered. Here's another example over here. The parameter can be anywhere within the URL. And in fact, URLs can have more than one parameter. I don't have an example of it, but it's fine. That can arise too. So here are my two questions. How do I tell React Router that there is a parameter within the URL pattern, if you like? And how does the component access that parameter value at runtime? So I'm going to illustrate it continuing on with our little example. I'm going to illustrate it as follows. Supposing in my sample set of samples, I'm changing the inbox to now look like something like this, the URL associated with the inbox to look something like this, where the 123 is, let's say, some sort of user ID or inbox identifier. And but it can be any value, obviously. So that's a design decision that I've made associated with my my kind of fake email client, if you like. So how do I express that this part here is a parameter or a variable within my routing configuration? And the answer is you do it like this. You include a colon followed by essentially the parameter name. You can call the parameter anything you want. It's completely arbitrary. So this is telling the React router that the first part is static, but this part is actually variable. So it could have any value. And no matter what value it is, then it's a match for this entire string, if you like. The component I want to have mounted is the inbox component. How does the inbox component get at the particular value at any particular point in time? And the answer is like this. This is my inbox component now. And it turns out that the parameter is passed as a prop. So up to now, props have been something that we've been in control of, but other third-party libraries might actually use props as well. And in fact, the React router does. So it's quite a long-winded expression, but it turns out that this entire expression is going to access the particular parameter value at any point in time within my app. And I suppose by sample 3, just to be sure now that you understand what I'm getting at here, if I bring up sample 3, or if I run sample 3, so this is the home page for sample 3. And just to illustrate it, I have 2 simple hyperlinks here. And if I click on the hyperlinks, look what happens in the URL. So if I click on this one, and I think I've just hard coded them. So the URL becomes /inbox/1234. Now, based on my routing configuration, the inbox component is mounted. And it looks like the inbox component is actually able to access the parameter value because I'm proving it to myself by displaying it there. Whereas with this link here, it's 4321. And again, it seems like I'm able to access it. So how am I able to access it? And the answer is back to here. This is the inbox component that's displaying what we just saw on the screen there. So it's just this big long expression that's actually accessing it. So this match prop, where does that come from? The match prop is a prop that is injected into my component by the React router library itself. Now, you do have to do something special though in order to ensure that props.match does actually evaluate to something other than undefined. And that is down here. So you just notice here that I've called my component base inbox, and I've done that kind of purposefully. And I am calling this function called with_router. This is a function that's provided by the React router library. I'm calling it and I'm passing a component, my component to it. And that is what I'm exporting from this file. And so that it's whatever is being returned by with_router, that is what is being injected into my routing configuration. Let me just explain that, sorry now. So we're on to sample 3, which is here. So here's my inbox component, which we've looked at, right? And I'm not exporting base inbox, I'm exporting whatever that returns. And if I go over to index.js, you can see here what I'm importing is whatever that with_router component returned, and that's what is being referred to from here. Now, so this with router function, which is a function that comes with the React Router library. Sorry now for jumping around, but if I go back to the inbox file again, you can see here I'm importing with router from the React Router library. So it's a special function, and what that function does is it takes your component and it injects additional props into your component. And that is what allows me to write this expression in my component. If I did not do this, then props.match would actually evaluate to undefined and the thing would not behave as I wanted it to behave. So this with router component, this with router function, it is a function, but it's a special type of function. It's what we call a higher order function. And a higher order function, it's kind of a React thing, really. A higher order component. A higher order component is a function that takes a component and returns an enhanced version of that component. The enhancement in our case is it actually adds some additional props, or it makes some additional props available to our component. Other higher order component functions do other things to components. But in the case of with router anyway, that's what it does. And that's what I'm documenting here, right? So there are two additional props that with router makes available to your component. This is the one that we're looking at right now. This is the one that we'll see later on. Okay, so that's a trick that we use quite a lot, these higher order component functions. They're called higher order components, but they're actually functions. I'll just pause for a second. I'm not sure if I flip through that too quickly, if people want to ask me anything about it.
I've got one question. I get an error when I've used that router, and it says something like the link must be contained within the router. Do you know about that error?
That's Storybook again, isn't it?
Yeah. That's Storybook.
Yeah, it's the same solution that I mentioned the last day. You need to use the decorator and you need to wrap the particular story with a decorator where the decorator provides a dummy router component for your component. That's a pretty long-winded technical answer now, but that is the answer. It's a fairly common problem, and that is the solution to it.
Yeah, because I saw my normal app was working, but then the Storybook wasn't working.
Yeah.
Okay, that makes sense. Okay.
If you Google memory router, a memory router is a very lightweight router component. It's not as functional as the router component that the browser router that we're using here. We're using browser. Sorry, now. I'll bring it up in the code actually. We are using this guy here, browser router. Okay, and that does all the things that I said it did at the beginning there. But when you're writing stories, you don't need something as heavyweight as this. Okay, and there is a lightweight one called memory router, and make your memory router a decorator for your story, and then it'll work. The links will work.
Okay, thanks.
Right. Okay. So that's this oddly named dynamic segments, but it's really parameterized URLs. And did we have them last week? We didn't have them in last week's lab. Maybe we will definitely have them in this week's lab. So you see them in action. And I've already made the point that there can be more than one parameter in the URL string if you want it. Just be consistent with how you express where the parameter is within the URL string, which is what I'm doing here. Now, up to now, our routing entries have been in the component at the top of my hierarchy, but in fact, you can have root entries nested within your own components, and these are called nested routes. So where you might use this nested route idea is if one of your components children is actually dynamically determined based on some characteristic in the browser's current URL address string. So the URL address somehow determines which particular child a component of yours should have. Yeah. Now, by way of illustration, I just kind of dreamt up this idea. So I've decided for my sample app that, well, we already have this, right? If the browser's URL is, if the pattern is something like this, then I want the inbox component to be mounted. However, if the browser's URL is /inbox/something/statistics, then I want the inbox component to be mounted again, but also I want this stats component to be mounted, where stats would be a child of inbox. If the browser's URL is like this, then I want the child of inbox to be a component called drafts, as in draft emails and statistics about my email usage, if you like. So the child of inbox is dynamically determined based on the suffix part of the browser's URL address string at any point in time. So how do I express that in my routing configuration? And this is an excerpt from to answer that, and it's sample 4. So here's my inbox component, and I've got root entries within it as just part of the ordinary JSX, and that's perfectly acceptable from a React Router point of view. The assumption now is, of course, is that this component will be mounted if the URL address begins with /inbox/ whatever. And what these two entries are now saying is that if there's an additional part onto the, these two here, if there's an additional part onto the URL address, then mount these additional components as a result. I am highlighting the fact here that make sure to use absolute paths here. Don't use relative paths, because that will cause you problems. So the paths are always absolute from the beginning of your your app's set of URL paths, if you like. Maybe I'll just quickly show you sample 4 working, but I'm not going to look at the code. I don't think you have the essential one. So again, I'm just illustrating it with hyperlinks. So if I click on this hyperlink, and again, watch what happens in the browser's URL address. If I click on this, the URL looks like this. So it's only the inbox component is mounted at this stage. The inbox component is generating this. Whereas when I click on this link, you can see the additional part, and my statistics component is just generating this piece of text here. Third example then is the drafts. The drafts component is just generating this piece of text. Okay, so have a look at sample 4 in your own time. That's nested routes. I don't use them in the labs, it turns out. I did in last year's lab, but not this year. And as I said, it's kind of part of your design process, deciding on what are good URL strings to have in your React app. I'm not going into good design, bad design, to be in fairness with you now, but it is part of kind of the design process. It kind of follows the whole REST URL principles, if you're anyway familiar with REST. REST is something that you will cover later on with Frank anyway. Back to the link component. The form of the link that we've looked at up to now is fairly straightforward. It just takes one prop, the top prop, and that accepts a string. And the link does what we said it does. But sometimes maybe when you click on a link, you actually want to pass some additional props to the component that's mounted as a result of clicking on that link. And those additional props are known by the link component itself, or they can be computed by the link component itself. That's a fairly common kind of requirement. And so how do we achieve that? And the link component actually allows us to do that. So, and I'm illustrating it in sample 5. It's kind of an abstract example, but in this case, this hyperlink here, which is implemented using link, it's actually implemented behind the scenes like this. And so how you interpret it, here's the kind of extended form of the link component now. So it takes a number of, in this case, the top prop is not a string, it's actually an object. And the object has a number of key value pairs. The path is obviously where you express what you want the browser's URL to change to when the user clicks on that link. The state is where you express the additional props that you want to make available to whatever component is mounted as a result of the browser's URL changing to this. And so this part here now is completely up to you, whatever key value pairs you want to use. The state is prescribed by the link component. It has to be called state, but whatever key value pairs you want to use here are up to yourself. So I've kind of arbitrarily decided I want to pass on, let's say, the current user. Let's say a user has logged in and I want to pass that user's user ID to my inbox component. Maybe it does some sort of API call, as I said. I couldn't think of anything sensible for a second prop, so I just made up something useless. So here are the 2 additional props that I want to make available to my inbox component. Let's assume that it's still this route is being used behind the scenes. So it is the inbox, my inbox component that is mounted as a result of the user clicking on this hyperlink. But the question is, how do we get at the 2 additional props? And surprise, surprise, they're made available to us through the props object. So this location object is another extra prop that is injected into our component by the React router. And it has a key called state, which matches state here. And all I'm doing here is just doing some destructuring, which we've seen from last week, I think. So here's where I'm actually accessing my 2 keys that I specified over here.
Can I ask you, is that
sure.
state passed as a in the URL as a parameter?
No, you don't see it in the URL. The URL, if we click on this link, the browser's URL will change to just that. Yeah, so it's not like the parameterized URL example. Okay. Now you may think I would prefer the actual user ID to appear in the URL, and I would prefer maybe this to appear in the URL. If that's the case, then you've got to go back to the parameterized URL strategy. Yeah. Sometimes you don't. Sometimes you do want them to appear in the URL of the browser. Sometimes you don't. What I'm showing you here is as you've probably, if you've done any kind of browsing around the web and used apps, the layout from a UI perspective of apps tends to be fairly standard at this stage. And by that, I mean, an app tends to have a standard header part, a standard or static footer part. There may even be a side menu that's static or constant. By static or constant, I mean, no matter how you navigate around this app, these parts, header, footer, side menu, remain constant. The part in the middle tends to vary. Okay. So how do we actually achieve this kind of standard or static header footer in our code? And it's, so I've illustrated it in sample, whatever sample, we're into sample 6, I think. I want each page in my little mini app, which only has 3 pages, a home page, an about page, and an inbox page. But I want them all to have the same header and footer. So no matter what page you navigate to or view you navigate to, that header and footer is going to remain constant. How do we implement that? And the answer is you can actually mix any of your own custom components into the routing configuration. And that's what you see here. So I've implemented a component called header and another one called footer. They're just standard components and they render the header and footer that I want. And you can look at the implementation, although I implemented them using the Bootstrap CSS library, which we're not using this year. I didn't transfer it over to using Material UI. But in the lab, I actually implement a static website header using the Material UI in this week's lab, I think. So you'll see that in action. So it's pretty straightforward really as to how you get these persistent elements or static elements within your, across your app, no matter what view you're on. Okay, that brings us up to sample 6. And if you look at the set of samples, I have also sample 7, 8, and 9, and I'll talk about them next week. I'm kind of covering this stuff as we need them from week to week in terms of how whether we use them in the labs or not. Okay, let's shift gear to a completely unrelated topic in one sense, and it's something called a virtual DOM. Now you know, and if you didn't, Frank would have covered it in the lecture that he did with you, albeit 4 weeks ago now, that the DOM is a data structure that is built and maintained internally by a browser. If we go back to the days of the static web, when a web browser receives a HTML page, it parses the content of that page and it builds a JavaScript object representation of that HTML. And having built that object representation, which we call the DOM, it then analyzes the DOM and paints whatever is required onto the screen. Then we know that if the DOM structure is modified, typically by JavaScript code that you might write and associate with a particular web page, if the DOM structure is modified, then the browser will detect that modification and it will reflect whatever changes have been made to the DOM. It will reflect those on the screen. So it keeps the DOM in sync with what is being displayed on the screen. Now, in the early days of writing browser-based apps, we had to write a lot of JavaScript code which involved interacting directly with the DOM data structure in the browser. And of course, the DOM was slightly different from browser vendor to browser vendor, so that caused problems as well. But as developers, we had to understand the structure of the DOM and we had to know how to modify it. And as well, we had to make sure, you see, when you're modifying the DOM, you've got to be aware of what would be considered good practice and bad practice in terms of DOM manipulation. Because every time the DOM changes, as I said, the browser goes through a repainting operation. And that can be quite slow from a performance point of view. So we had to, as developers, build up knowledge in terms of what were good practices and bad practices relating to DOM manipulation. And there were certain things that you should avoid trying to do to the DOM. For example, rather than modifying particular aspect of the DOM directly, the advice, for example, would be take a copy of that particular part of the DOM. The DOM, by the way, is just a hierarchical object structure. If you wanted to modify a particular part of the DOM, then the advice was make a copy of that particular part, modify the copy, and then just essentially overwrite the original part of the DOM with your copy as one operation, and you would get better performance from the browser in terms of repainting the screen as a result. And there were lots of other practices as well. Now, the React team reflected on, should we expect all developers to have the necessary knowledge to be efficient in the way that they actually manipulate the DOM structure itself? Can we make that assumption? And they decided, no, it probably wouldn't be a good assumption to make. And so they took that responsibility away from the developer and they made it part of the React library itself. So the React library now takes care of making updates to the DOM on your behalf. And it's quite a sophisticated algorithm that is used to do that. And it does it in an efficient way. That's kind of a big statement, but it ensures that any DOM manipulation that it carries out, it's done in an efficient way. So what really happens behind the scenes, we write components and we implement a component hierarchy. The React library takes our component hierarchy and it builds a DOM representation of our component hierarchy. And we call that DOM representation the virtual DOM. And then it uses that virtual DOM. So anytime you're a particular component in your hierarchy goes through a state change, we talked about this last week, and our component hierarchy goes through a re-rendering, then the re-rendering is going to be making modifications to this virtual DOM structure. And having completed the re-rendering on a particular state change phase, if you like, the DOM now knows what the current state of the virtual DOM is and what the previous state of the virtual DOM is. It has two copies of the virtual DOM now. The state of the virtual DOM before the state change and the version of the virtual DOM after the state change. And it does a diff operation between those two virtual DOMs, and it uses the output of that diff operation to determine what changes it should make to the actual browser's DOM, which I refer to as the real DOM. So this is what's going on behind the scenes when our React app is active and the user is interacting with it and the interaction is causing state changes, as we talked about last week. Those state changes are resulting in React making modifications to this virtual DOM data structure, which the virtual DOM is a very kind of lightweight mirror of the real DOM. It's modifying the virtual DOM and it then analyzes the changes that it has made to the virtual DOM and performs a single kind of batch update to the real DOM. It does that at the end of every re-rendering phase that it goes through. Which is what I'm documenting there, okay? And you can read over that yourself. So it's doing all the heavy lifting, if you like, and it's taking real DOM manipulation away from the responsibility of the developer, because the developer may not perform it in an efficient way. Now, there is a slight kickback against this virtual DOM notion in more recent, almost months, maybe years. There are a number of single page app frameworks that followed this virtual DOM approach. And again, the virtual DOM was a unique feature of React at the time. But there is a slight movement against the virtual DOM. I won't get into it now, but it may not be a core part of single page app frameworks in the future. We're not sure really, but I'm just flagging that point. What's the whole point of this? It meant that, you see, before React, the DOM manipulation code that you had to write was quite long-winded, quite bloated, and because it's no longer appears now, it's no longer evident in our code. Our React code is arguably, it's certainly declarative, but it's a much cleaner kind of code than it would be had we to write our own DOM manipulation code. Also, certainly React was more performant in terms of it optimized the DOM manipulation aspect of browser-based apps, which meant that you got better performance, really. That was the whole point behind the introduction of this virtual DOM. It wasn't so much just to make your code cleaner, it was actually to try and make your app more performant. And so we had this last week, actually, yeah. So down here now is really where all this virtual DOM stuff is going on. This was the very simple counter component that we had, and the user clicked the button on the counter. That triggered a state change within my component. And having completed the state change, the component re-renders. But of course, the re-render now means that the virtual DOM has been updated. Yeah, the virtual DOM has now changed, and React then compares the new DOM, the new virtual DOM, sorry, with the previous version of the virtual DOM. We refer to this, or it refers to this as the pre-commit phase. Pre-commit as in it has not committed any changes to the browser's actual DOM yet, the real DOM. So it goes to React, the React engine goes to a pre-commit phase, and that could be quite involved if it's if you've got a very deep component hierarchy in your app. So it's essentially evaluating what changes do I need to make to the real DOM, and then it commits those changes to the real DOM, and we refer to that as the commit phase of the React engine's behavior. And having then changed the actual DOM or the real DOM, then the browser repaints the screen as it always would. This was from the Filtered Friends app that we talked about. And here I'm explaining what happens when the user types a character into the text box. And we had our component hierarchy, and now we can be more specific in terms of what's actually happening behind the scenes in terms of React, the React engine, and the role of the virtual DOM, etc., etc. From a performance point of view, this is where the performance improvement was achieved by React. Okay, this is still the most CPU intensive part of changing the view, if you like. You know, the browser actually repainting the screen is the part that is most time consuming of all of this activity here. This is minimal really in terms of how much CPU it consumes. But it still made React apps more performant than their competitors at the time. So that's this whole virtual DOM. Yeah, like when I was explaining this last week, so what we'd now say is that if this component goes to a state change, every component re-renders. We know that from last week. But maybe if you take this side of it here, this side of the hierarchy, maybe the props that were passed down here as a result of this going through a re-rendering, maybe those prop values were the exact same, which meant this component, even though it re-renders, it doesn't need to make any change to the real DOM. And similarly, this one and this one, they re-render okay, but they don't actually cause any change to happen, or should cause any change to happen to the real DOM. So while these three will re-render when React goes through its pre-commit phase, it will determine there's no change to the virtual DOM being caused by these three components for this particular re-rendering. Therefore, I can completely ignore this when I'm computing what updates should happen to the real DOM. That's the advantage of it. Now, wouldn't it be better though if we could tell React, look, the props here haven't changed since the previous state change that occurred here. Therefore, you don't even need to go through a re-rendering of these. Now, we would actually have to tell React that though. It can't make that decision for us. And there is ways, very simple ways of indicating that in your component implementation. I don't go into it. It's something called memoization. You can look it up yourselves if you want to.
Sorry, how do you spell that?
Memo, M-E-M-O, and then it's just ization, M-E-M-O-I-Z-A-T-I-O-N. Memoization, you're essentially kind of caching the components, if you like, and yeah, it's very simple actually to achieve it. Now, it's simple to achieve it just by saying, well, if the props haven't changed, then there's no need to re-render. There are other aspects to memoization as well, which I'm not going to go into now. But if you, like I say, if you Google it, then you'll find all you need to know about it. That's that topic. Next topic, design patterns. So design patterns is an aspect of software engineering. It's not an aspect of React development. And what are design patterns? I'm kind of giving you a definition of what design patterns are here. I'm saying that they are general representation of solutions to commonly reoccurring problems in software engineering. Now, we've had about 4, maybe 5 decades of software engineering at this stage, 6, some people would argue, decades of software engineering. So in terms of the kind of problems that we're trying to solve at a kind of a small micro level now, be it a class or a method or a function, the kind of problems that we're trying to solve have probably occurred in other projects. And so the solutions to them have emerged, and good solutions and bad solutions, and in particular good solutions, have emerged over time. And we tend to refer to these, or we refer to these efficient and well-designed solutions to these common reoccurring problems as design patterns. And so what a design pattern does is it helps you to structure your implementation of a particular solution to a particular problem that you have, because the problem that you're trying to implement a solution to has occurred elsewhere, and somebody has gone to the trouble of documenting and refining the structure of the solution to the implementation for that particular problem. And we refer to these things as design patterns. So there's a whole kind of catalog of design patterns that have emerged in the industry over the decades. It's a topic in itself, really. In fact, we used to have a module on the MSc called design patterns. It's still there on the books, if you like, but it hasn't been taught now for a couple of years, but it is a very large topic in its own right. And it's all about helping software engineers design well-founded solutions to particular problems that they have in whatever application or project that they are developing. So you kind of build up this knowledge over time, I guess. It kind of relates to these high-level principles of software design. We're always trying to achieve reusability within our code base. whether that's reusability of within our project or being able to develop modules that can be reused in other projects. Separation of concerns is another kind of design objective. We'd like each module within our code base to have a single responsibility or a single concern, and those concerns should be separate from the concerns of other modules. Now, what's a module? A module depends on the nature of the programming language, I suppose. A module might be a class, it might be a method of a class, it might be a function. Doesn't really matter whether it's coarse-grained or fine-grained. These notions of reusability and separation of concerns and single responsibility, which I haven't mentioned there, these are all high-level objectives, I suppose, when you're doing any kind of software development, be it browser-based apps or otherwise. We also talk about the DRY principle in software engineering, don't repeat yourself. It's kind of linked to reusability and separation of concerns. It's obviously not a good idea to have repeating code across our code base within our project. We abstract that repeating code, put it into a module on its own and invoke it from wherever it's needed, and maybe parameterize it so that it can be reused. We're all familiar with these kind of high-level principles or objectives. Kind of related to all of this is when you're trying to achieve dryness, as we call it, within our code base, there are two kind of high-level strategies that you can use. One is called inheritance and the other is called composition. I'm sure everybody is familiar with inheritance from mainly if you've done any kind of Java programming, or if you've done programming in any class-based programming language like Java or Python or C# or whatever, then inheritance is a big part of those languages, and inheritance is part of those languages so that you can achieve dryness in your code base. We often kind of use this term that inheritance is all about trying to model is-a type relationships in your problem domain. You're looking for these is-a type relationships, and when you find them as you're doing your modeling of your problem domain, then you represent those relationships in your code using inheritance. So what do I mean by an is-a relationship? Here's an example of an is-a type relationship. So they're all indicators of some sort of inheritance hierarchy that's evident in your problem domain, whatever the problem domain is. Now, there is an alternative to inheritance, and it's called composition. And we often say the composition is about analyzing your problem domain and looking for has-a type relationships. For example, a car has an engine. So if I was implementing this in Java, car would be a class, but one of the properties of the car class would be an engine property. Whereas up here, obviously, you know, automobile would be a class and car would be a subclass of it. So it's a different way of looking at the world, if you like. One is looking at it through the inheritance prism. Another way of modeling a problem domain is modeling it through the composition prism, if you like. Now, where I'm going with this is, I'm pretty sure everybody has some experience anyway of inheritance in code that they've written, but you may not have experience of composition. And it turns out that React actually favors composition over inheritance as its way of modeling a problem domain. And so what it means, coming back to the core kind of concepts of React, it means that we like building components from other components. Okay, so in other words, we're composing a component by using other components. That's where composition comes in. And so, I mean, the simplest form of that is if you've got three components, one uses the other two as children and it passes props down to those children, then we could say the component at the top is composed of the two underneath it. It's a very simple example of composition. It's the simplest example though. There are other ways of achieving composition other than that simple kind of hierarchy that we've seen so far. It's often kind of, this is another way of thinking about composition in relation to React and components. It's about trying to code up or implement generalized components and then using them to build other components. Now, the generalized components, how do you make them so that they're specialized? Well, one way might be passing props into them, but the props could be anything in terms of form. The props, we know the props can be data, but we also know now that we can actually pass functions in as props to a component. So we're essentially passing behavior into a component. So the generalized component may expect to receive function props to flesh out what that component does for any particular use case. Thirdly, maybe we could actually pass a component as a prop to another component. So the generalized component now is expecting props potentially that could be data, functions, or other components. So generalized components are used in building many other components, yeah, and props are the way through this. So props really have a major role in React. It's not just for passing data from parent to child in a unidirectional kind of data flow. That's the only, we might think that's the only use case for props, but it has a wider kind of role. Now, to kind of bring this back to the area of patterns and how can we go about achieving good kind of composition in our design, there are a couple of patterns that are commonly reoccurring patterns, and I will use them in the labs. Well, I'll use two of them anyway. One is called the container pattern, the other is called the render props pattern, and then there's the higher order component pattern. We've actually seen the third one in the React router, by the way. So the container pattern, I'm going to talk about that one this week, and I'll talk about render props next week, and we will use the container pattern in this week's lab. So you'll have an actual illustration of what I'm trying to get across here. Before I talk about the container pattern, I just want to use define a term, which is fairly straightforward, really, this notion of children. And I'm going to define the term children here in the context of just ordinary HTML. So we would say, if we look at that little excerpt of HTML there, we would say that the div element has two children, the H2 and the UL. We would say that the UL element has 3 children. And they're all LI elements. So there's that kind of parent-child relationship, which we're kind of familiar with already anyway. Now, back to the container pattern. And I'm saying here that all React components have a special children prop. We haven't seen it so far. And the children prop is used so that the consumer can pass components directly by nesting it within its JSX. Here's an example. So I've got this component called the picture component. I would refer to this now as a container, which we'll come back to in a moment. But notice here in the picture component, and I've kept it as simple as possible, within its JSX, I'm referring to props.children. Where does that get instantiated? It gets instantiated by the consumer of this picture. The consumer is a component that uses my picture. So here's a consumer. And here I'm using the picture container. Now I'm passing it an ordinary prop. So maybe this might be the URL of some image that I want my picture component to display. But between the open and closing picture tags, I can nest any JSX that I want to in here. And this JSX as a unit will be bound to the children prop over here. So essentially, you can think of it as I'm passing this to my container component, and the container component will render it for me. So the consumer is telling the render component, the consumer is telling my picture container component what it wants to render on its behalf. And the way we code it is like this. So we're composing picture with this in order to achieve our outcome. Hence, we're using composition. It's easy to, relatively anyway, it's easy to understand that, right? The difficult part of all of this is looking at your code base, standing back from it and realizing, in fact, I could refactor this code and use the container pattern to implement it instead. That's kind of the tricky part. Explaining the container pattern is straightforward, and understanding the container pattern is straightforward. It's straightforward. It's knowing when and seeing opportunities to use it. That's the tricky part, in fairness, but that only comes with practice. So that's 101 example of this container pattern. So I would refer to picture as being the container in this case. So a picture component displays its own JSX. Its own JSX would be the image tag in this case and nothing else, as it turns out, and maybe the div as well. And the div might have a CSS. It doesn't in this case. So the picture component displays its own JSX, as well as that passed by the consumer component, which is the one on the right. And it's passed via this children prop. The children prop has always been there, available to us in all of the components that we've written so far. But of course, we haven't done anything like this so far. Although we might have done it in Material UI actually in passing, but now you can actually, Material UI uses this container pattern quite a lot, you see, as it turns out. So I've just kind of randomly dreamt up other uses of my picture container. So here, this consumer, it looks like it wants the picture component to render a series of buttons. I'm saying it's rendering them after the image, but that would be dictated by CSS. We needn't worry, excuse me, about that. Here's another consumer that's using the picture container to render a list after the image. And it could be anything you want to be, really. Okay, so we are reusing the picture component in a number of different use cases, i.e. reusability, or to express it another way, we are composing the picture component with other components in order to achieve whatever we want to achieve. Okay, so that's the container pattern, and as I said, it's easy enough to understand it when it's just simple examples shown to you. The tricky part is being able to identify cases where you can use it, and it's often part of refactoring. You don't spot it initially. If you're very experienced, maybe you do. You can spot that I can use the container pattern here before you start writing a particular piece of code. But more often, it's a case of identifying opportunities to use it after you've done your initial implementation. So just going back to that. So I've explained the container pattern. I'll talk about the render props next week. And I won't really look at higher order components other than just explaining the general idea behind them. But they all have the same purpose. They're all concerned with trying to achieve better reusability, better separation of concerns in your code base. So some people often say, I don't understand the difference between container and render props. And in a sense, there isn't a difference in that they're trying to achieve the same thing. There may be some cases where you have to use render props, you can't use container. But in many cases, you could use one or the other to improve the quality of your code, i.e. improve reusability and composability between your components. So composability is not always just a component hierarchy. It's easy to implement component hierarchies. It's standing back from that hierarchy maybe and flattening the hierarchy a little bit. And that flattening can be achieved using these patterns and other patterns. I think I've made those points already. So they're the benefits of the container pattern. You can read that yourselves. I'll pause for a second just in case. Oh, okay. Right, next topic, custom hooks. This is straightforward enough, really. A custom hook. What essentially custom hooks allow us to do is to extract any state manipulation state in the sense of the state associated with a component that we had from last week. Extract state-related manipulation code, extract that from your components and put them into separate functions. The state manipulation code can be quite long-winded and it does clutter up our component implementation. So it's nice if you can actually just lift that code out of your component implementation and put it into a separate module, where a module in this case would be a function. Perhaps with the objective of reusing it, but even if you don't reuse that function, it just cleans up your code a little bit. An example, so this probably comes from, looks like it comes from some sort of library system or bookstore system or whatever. So I've got a component, presumably that displays in a page that displays information about a particular book, and buried within the component, I've got some state manipulation code using my two hooks that we saw last week, the useState and useEffect hooks. So what would be nice is if we could just lift all of this code out of the component and put it into a separate function and invoke that function. It just cleans up my book page component, and maybe I can reuse that function elsewhere as well. That function that I would put it into is what we call a custom hook. So the solution looks like this. So here's my custom hook, and all I've done is I've literally lifted the code and pasted it in here. Now, you do, in most cases, the function will need a parameter. In this case, the parameter would be the ISBN number. If you go back and look at the previous slide, then I do obviously have to pass the ISBN number into my custom hook function here. But other than that, it does what it did before. The other thing is, what should your custom hook return? And that's very much up to you. But typically, whether it's a custom hook or it's a built-in hook, like the useState and useEffect, typically hooks, if they have to return anything, typically they return some form of a collection, whether that be an array or an object with key value pairs. And again, it's a design decision as to what it should be for your particular custom hooks. What I've decided to return here is return the current book and a setter for book. But again, it's kind of up to you. In terms of invoking my custom hook, then here's my book page component now. That's much cleaner. Okay, so we reduced it to this one-liner here. It's important that you, whatever name, this is a function that you're writing, so you can give it any name you want to, but because this function is going to act or behave like a hook, then we should prefix its name with the use prefix, because we want the same rules to apply to our custom hooks as applies to the inbuilt hooks, i.e. our custom hooks should only be invoked at the top level within a component. We should not be invoking this use book function from within an if statement or some sort of loop construct within our own components over here. That's not going to work because we still have those kind of overriding rules associated with use state and use effect, which I mentioned last week. They can only be invoked at the top level. The fact that I've delegated it to a function doesn't change that that rule, if you like. And that's really all custom hooks are. So it's quite easy to refactor your code so that you can have your own custom hooks. And I think I've mentioned everything there. I'm actually going through this stuff quicker than I had expected. I hope I'm not going through it too quickly for you now, but I've made all those points.
Oh yeah, quick question. Those custom hooks, where do you put them in your source code?
You can put them anywhere you want to. Just put them into typically into a separate file. You could have maybe a number of custom hooks in the same file. You could have a custom hook per file. Doesn't really matter.
Will they get compiled so they'll be usable all over the application?
Yeah. Yeah. No, I'm not exporting it here. I should have an export statement here, exporting this guy, I guess, and then over here I would just import it. So it just follows the basic rules of JavaScript modularization, really. Other than that, there's nothing special. It's just an ordinary function with the caveat, though, that we know with the caveat that we shouldn't be calling, we shouldn't be invoking use book. Well, it's not so much that we shouldn't, but if you try to invoke use book within, let's say, an if statement inside here, then the transpiler will throw an error back to you, saying that you're violating one of the basic rules of hook usage. And I do that anyway. In this week's lab, I take some of the movie state management code and I put it into its own custom hook file. I think I only have one example of it, but there were a couple of places that I could have done it, but I didn't. You can do that if you wish. Now, in the slides, actually, as I said, I'm actually going through this quicker than I expected, but in the, so we've worked our way through these slides here, and I just have one or two other ones in it, in kind of available to me, just in case I did have some time available to me, and it turns out that I do. So there's just one small little JavaScript thing that I want to cover here. So you don't have, if you're following the slides from the PDF that's available from the website, you won't have the remaining slides I'm just about to go through here. So I'm just calling this a little bit of ES6 top up. And I just want to mention the spread operator. So the spread operator, I think it came in ES6, it could be ES7, I've lost track really. But the spread operator is this triple dot operator, okay, which you may have come across. And what its function is, I'm saying here, is it's a new operator that takes a collection, i.e. an array or an object, and it spreads out the elements of that collection into its individual parts. That's what the purpose of the spread operator is. Now, when and why would we use the spread operator? Here's one use case. If you actually want to make a copy of an array, then the spread operator is a useful, quick-handed way. There are a number of ways we could make a copy of an array, but this is a kind of a one-liner, if you like. So I'm illustrating it by means of this example here. So let's just step through it one by one. So I'm just declaring an array, that's fine. And I'm declaring a second array here. And one of the elements in the second array is the first array. Now, when I do that in this way, when I add the first array into the second array, it actually appears like this, right? Which is maybe what you want, but maybe it isn't. Maybe what I really want is I want the elements of this array to be scattered amongst the elements of its containing array. Yeah. And by including array 1 here, that won't work for me, because we can see here when I do a console.log of array 2, we can see how it actually displays. If instead, though, I stick the spread operator in front of the array, then it takes the elements of this array and it spreads them, hence the name. It spreads those elements into the containing array, which means when I do a console.log of array 2 now, I get this here. Okay, I haven't made any change to array 1. So that's one use case for the spread. Sorry, did I say that was for copy? That's not for copy. That's really more for inserting one array into another array. That's one use case. Another use case, this is the copy use case actually. So again, just by way of example, so I've got this array here, and clearly this is just making assignment. It's not making a copy. So array 2 and array 1 are now referring to the same physical array by means of, as a result of this statement here. So if I make a change to array 2, I'm pushing some entry onto it, I'm effectively changing the source array, of course. So array 1 is now going to be affected by this statement here. Array 1 is now also going to have the D element in it, because it is the same physical array that both array 1 and array 2 are referring to. So in other words, this line here is not achieving a copy in any sense. However, if I do it like this, if I say array 3 is equal to this expression here, what this does is it creates a completely new array, and the elements of that new array will be copied from array 1. But array 3 now is a completely separate array, and I can prove that to myself. If I push something onto array 3, and then I do a console.log of array 1 will not contain this extra character. So that proves to me that this expression here has made an actual copy. It's created a completely new array where it contains these elements. And even I could put some additional entries as well if I wanted to. So that's using the spread operator as a shorthand for array copying. Array copying is something we always wanted to be able to do, but it took a couple of lines of code to do it prior to ES6 and prior to the spread operator. That's the spread operator used on arrays. We can also use the spread operator on objects. Kind of has the same purpose. And again, I'm just illustrating it by way of example. So I've got the part me object, and then I've got the all me object. And in the all me object, you can see here, I'm including the first object. And this is the way I'm including it the first time. Okay. But by doing it like this, when I do a console.log of me, this is what I get. Okay. So it's actually included a new key called part of me, with that as its value. Now, maybe that's what I wanted to achieve, but more than likely what I wanted to achieve over here was I wanted these key value pairs to be spread amongst the key value pairs that are appearing in this array. I didn't want it to appear like this. And so how do I do that? This is how I do it. Again, I stick the spread operator in front of my nested collection. And so now when I do a console.log of me in this case, then this is what I get, which is probably what I want to achieve. Here's another use case of it. If you want to kind of update, often we have an object and we want to update a particular property in that object, update as opposed to add a new property. Here we're kind of adding new properties. to the all me object. Here I want to update the address, I think. So here's my initial object, and then I've got this expression here. So what this is doing is this is going to create a completely new object. It's taking all the key value pairs of the me object and putting those into the completely new object. Now, one of the keys in me is the key called address, but I'm adding on a new property here, which also has address as its key. And really what is going to happen is, because this appears after the address that appears in this object, I'm effectively reassigning a new value to address. So there's obviously only going to be when this entire line of code finishes executing, there's only going to be one entry that has the key address, and the one that's going to apply is this one as opposed to this one up here. So when I do the console.log of me in this case, oops, sorry. When I do the console.log, I get what you see on the right-hand side there. As in, here's the address that has been updated. Now we're using the spread operator there, if you like, on the right-hand side of an assignment statement. And its effect is, as I said, it spreads the elements out. If you use the spread operator on the left-hand side of an assignment statement, it kind of has the opposite effect. It gathers things in together into one unit. And we often refer to that as the rest operator. There is no separate operator called rest. It's still the three dot operator, but it's the use of the three dot operator on the left-hand side of an assignment statement. So they just gave it a second name, but it's still really the spread operator. But its behavior is different. So here again, by way of example, I have array defined as that. And then on the second line, I'm using object destructuring now, which we've seen before. So I want to destructure this. And in particular, I want to pick out the first and second entries. Oh, sorry, array. Sorry, give me. Oh, yeah, sorry. So this is destructuring of an array. Okay, maybe we didn't cover this really, but the effect here is that this is going to declare two variables called first and second. First is going to be assigned A, second is going to be assigned B, and I'm declaring a third variable. This is actually a variable. Okay, I've called it rest, but I could have called it anything. And because I put the three dots in front of it, this third variable called rest is going to be assigned the remaining elements within my array. So it's going to be an array containing C, D, and E. So it has gathered up the remaining elements in this array and put it into a new array called rest. You can call that anything you want to. We tend to use that variable name rest though, because it has a certain meaning. You can do the same with objects, and you can see here.
Sure. Isn't the comment behind the console log rest says something else?
Pardon, say that again.
So on the block that you were just talking about, you have the result of console log rest. It's not doing what you said it would do.
Oh yeah, sorry, that's a mistake. Well spotted. Yeah, it should be C, D, and E. A and B should not be there at all. Thanks.
Okay.
Did I get this one right? Let's see. Console.log of rest. I think I did. Did I? I think I did. Yeah. So this is the rest object, and this console.log generated this here. Did I get it right? I did, yeah.
Dermot, okay. Can I just ask you a question there? Going back there to the question that that Warren had, does that mean that when you console.log rest above there, A and B are not included?
Correct.
And it's just the remainder, if you like, of the array?
Correct,
okay.
As an array. So
okay.
rest will be an array containing C, D, and E.
Yeah.
Yeah.
So what you've listed first, they're to be excluded.
Yeah.
Okay.
Yeah.
I see.
Okay.
Okay.
That's a mistake.
Okay. Thanks.
Great. That's it. What time am I? Right. I'm on the hour. That's all I wanted to cover. We have 10 minutes or so. You're probably too tired now for this, but I don't know if people had any initial questions in relation to the assignment. Maybe not. Sorry, not. Maybe it's a bit late in the evening for it, but will I let it go?
Yeah.
Could you explain what it is you could be looking for in the assignment?
If you're going to go the movies app route, then take the end result of next week and add more functionality to it. Now, by more functionality, I think you should look at the TMDB API website. Like what I'm doing in the lab is I'm accessing three endpoints of TMDB. I'm accessing the discover endpoint of TMDB that sends me back an array of movie objects. I'm also accessing the review endpoint of TMDB that sends me back review objects about a particular movie. I'm also accessing the genre, but that's not that important. So if we take those two, the discover endpoint and the review endpoint. Now, there are many other endpoints. There are endpoints that will return information about actors and actresses. There are endpoints that if you give an endpoint a movie ID, it will return an array of similar movies. There's another that's called the similar movies endpoint. Surprise, surprise. There's one called the recommendations endpoint, which is if you give it a movie ID, it will return back an array of recommended movies based on kind of people's recommendations, I suppose. So there's all of these other endpoints available to us from TMDB. And if you took those endpoints and build those into our movies app, so wouldn't it be nice if when we click on a movie, we get details on a movie, and then maybe there's another link that I can click on that shows me all of the crew and cast for that movie. And that shows me images of the people and maybe some facts and figures. And maybe there's another link then on that page, which if I clicked on, it gives me all of the movies that that person appeared on. Okay, so I'm fleshing it out to make it a much more user informative app. At the moment, it just gives me 20 movies and reviews on those movies. But TMDB has lots of other information around that whole area that we can use.
Yeah, okay, sounds good.
Yeah. So do spend a little bit of time just poking around the TMDB and reading on it, and then you'll get your ideas from there, really.
Okay.
If you're going a completely different route and you're starting something from the ground up, then we need to talk about that separately, really.
Sorry, one thing I've been battling with is maybe import statements, things like that. Is there a best practices, I suppose? For instance, how to create our folder structures. I've looked at some GitHub projects and they do it differently. And what is the best way to go about that?
I wouldn't say there's an easy answer to that, really. I've just kind of, if you look at the way I've structured it for the movies app, where I have the components, the pages, etc., that kind of folder structure, that for me was based on, just like yourself poking around from reading articles and coming up with that structure. So there isn't a one solution and a best practice that everybody follows. You will find different practices, to be honest about it. I'm not sure if I'm going to be looking at that aspect of what you submit. I definitely won't. But it makes sense that you would have a components folder, a pages folder, hooks folder, and again, follow that kind of outline that I did for the movies app. There's quite a lot of detail there, I think, which is pretty reusable no matter what the nature
Okay.
of.
So what I was worried about is that basically if we don't do it the way you done it, it would be bad. But
No.
I do find some guys have done it in a way that is quite useful. So I've followed them where that made sense. The other thing is I'm finding this thing that the more advanced guys are almost extending components. Are we expected to do that?
What do you mean by that now, I wonder?
So they're kind of using like objects. They're kind of extending other things. That's the best way I can describe it. I might have to send you an example of where I've seen it.
Yeah, I know about object extension, all right, but I wouldn't say, are they using it in the context of a component though?
I have seen that, but it seems to be very advanced because it tends to be a very complex code.
Yeah.
And I was just worried we'd be evaluated on that level.
No. If you look at I've tried to give as much detail as I can in the grading spectrum. So yeah. I think if you follow that, and if there's any aspect of that you're not too clear on, yes. Then for sure come back to me on it. But I know what you're talking about there in relation to object extension, but that's extending kind of ordinary objects that contain key value pairs and that represent data, and merging of data objects. That's where I've seen that object extension syntax used a lot. I haven't seen it used in relation to, unless now you're talking about, class-based components as opposed to function-based components. I
think I need to give you an example and just ask you about it.
Yeah. Send it on to me on Slack. I'd be interested.
Okay.
Great. Okay, folks, that's great. So I'll have a quick Zoom session at the beginning of Thursday's lab to allow people to ask me any other questions that they might have in relation to the assignment. Right, I'll talk to you then.